Another quite common data modeling use case is that you have products of many different categories, and each of these categories needs different product attributes to describe the product properly. Of course, you could add all the necessary attributes to the product class itself, but besides being quite confusing for the editors and the users of having hundreds of different attributes which are empty most of the time, at some point you also will hit limits of the database. So Pimcore provides you two other ways of dealing with that requirement in a much more elegant way. The first option are so-called object bricks, which allow you to extend the data object classes with additional attributes on object level. Let's have a look how this can be established and configured. To do so, let's go back to our test class and add another data attribute, which is of the type object bricks. You can find this again in the structured section here. And yeah, let's just call this attribute bricks and save the data class definition again. The object bricks themselves are defined again in a central place, similar to the field collection, actually pretty the same as the field collections. So let's just open up the object bricks, and there we can now define our different object bricks. And yeah, similar to field collections and class definitions, again, you can choose between the layout components and different data attributes. In terms of the data attributes, you have again pretty much the same data attributes available that you have also available for the field collections. Let's just add here one simple data attribute and save this object brick. In opposite to the field collections, for the object bricks, you have to define within the object bricks for which object classes they should be available. This can be done here in the general settings, where you have to choose the classes and then also define the data attribute, the endpoint, where you want to be able to add this object brick here. Let's also add a few other object bricks I have already prepared before to not need create them all live here. Of course, you can add multiple object bricks here. Let's just add 3 of them and then go back to our tests object, open up the attributes tab, and there we already see the bricks data attribute, where we have again the possibility to add these object bricks. The difference to the field collection here is that object bricks can only be added once to a data object. Field collections can be added multiple times. And this, of course, results in a few other things that are possible with the object bricks. For example, the object bricks support the data inheritance. That means when we open up our sub-object, then we see already that we have all the already added object bricks available here, and that we also, of course, inherit all the values that were set on the parent object. And I can override the values on attribute level. That means the inheritance is only interrupted for the attribute which we changed in value. All the other attributes of the same brick, and of course also the other bricks, still inherit the values from the parent object. So the object bricks allow you to add additional attributes to data objects on object level, and so model the use case of having category-specific attributes. The second part of the Pimcore caching system is the so-called output cache or full page cache. This full page cache is, as the name already suggests, a cache that caches the full pages of the responses of Pimcore, and on subsequent requests delivers these responses directly out of the cache without starting all the MVC stack of Pimcore. So this output cache sits in front of the whole MVC of Pimcore and of course tries to optimize the performance even further. The output cache is not active by default and needs to be activated by the system settings, and there are a few settings that you need to be aware of. Let's just go for the full page section here, and there you can enable or disable the full page cache. If you enable this full page cache and don't set a lifetime, then Pimcore tries to automatically manages the output cache, and that means that it clears the output cache all the time if anything changes within the Pimcore backend or in general within the Pimcore data. So every time you save and document a data object, an asset or whatsoever, then the whole output cache is cleared because Pimcore does not know which data is used in the templates in the controller, and so it needs to clear out all the output cache. This is good because it makes sure that you always get the most current data in your responses, but of course this also can have some side effects and not so good effects, especially when you have a really dynamic system where a lot of data is stored all the time, a lot of data is updated, if there are importers constantly running and changing the data, so that all the time the output cache is cleared. Actually, in this case, it can be even worsen the performance because the elements always need to be loaded directly out of the MVC stack and then need to be cached, and then even before they are delivered once more out of the output cache, they are cleared again because some data was updated, and then all starts over again. So if you have a really dynamic system, then it might be useful to set a certain lifetime. And once you set this lifetime, Pimcore does not clear the output cache if any data changes in the system, but only the lifetime defines when elements are removed from the output cache. This has, of course, the effect that not all the time the cache is cleared when something changes, but on the other side, the downside of this actually is that once that it's possible that Pimcore delivers outdated data to the in its responses because the lifetime wasn't over yet, and so the data is still old. It's important to know, and you have to decide basically on your use cases whether to enable the full page cache at all, and if you enable it, if you just enable it, or also set a certain lifetime. In addition to the lifetime settings, there are a few more settings that can be specified in the full page cache configuration, like certain exclude patterns, where you can define certain URL patterns that should be excluded from the cache. And you also can define certain cookies that once they are set, the cache automatically is deactivated. In general, the cache key for all the output elements is more or less the URL with a few additional information, like whether the browser is able to work with WebP images, or if it's an AJAX request or a normal request. Pimcore also sets a few headers into the responses it sends to the clients. First of all, some standard headers like the cache control header and the expires header, which allow you also to define or set up systems like Varnish and other external caching systems. And in addition to the standard headers, Pimcore also sets a few custom headers, which are in the cache context the xPimcore cache date and xPimcore cache tag, which allow you to debug and verify if a response is delivered directly out of the cache or not. What is also important to know is that there are certain reasons when Pimcore automatically deactivates the output cache, even if it's enabled in the system settings. Reasons for that are, for example, if a user is logged in into the admin session, or if the debug mode is activated, or if a session is started, or some other reasons. And to give you a hint why an output cache is deactivated, even if it should be activated, Pimcore sends another header which allows you or gives you the information or the reason why it's deactivated. And this we have a look right here in this live request now, where there is this X Pimcore output cache disable reason header, which tells you why a response is not delivered out of the output cache, even if it should be. In this case, it's because we are logged in the backend with the same browser session. So finally, it's time to log in into the Pimcore backend interface and get an overview there.
To do so, let's log in into the admin backend interface of our demo application and see how it looks like. On the left side, we have a left side menu which contains lots of different features and configuration options that Pimcore provides you in the backend interface. We will discuss a lot of them in the course of the different Academy sessions. On the bottom left corner, we have a notifications section where Pimcore sends out system notifications like debug mode or any configuration problems, and where you can send notifications to other Pimcore admin users and also, of course, open received notifications. In addition to the left side menu, we have an accordion which contains 3 tabs, which are documents, assets, and data objects. These tabs represent the 3 main data entities that can be managed within Pimcore. We will discuss all the details of these entities in the corresponding detail courses. Most important things are though that all the data entities are managed within folders and that each of these data entities has an editor which can be opened in a multi-tab section where you also can switch between the different tabs. Each editor contains a toolbar which provides certain features that are necessary for this entity, like save or delete or reload and different other things, and then a tab bar which contains all the information of the entity itself, so all the data, and also additional features and configuration options that are provided by the opened element. Pimcore has a context-sensitive user interface. That means if you're looking for a certain functionality at a certain place, try the context menu. Pimcore provides context-sensitive context menus where a lot of different features and options are available, depending on the context. So the actual user interface itself can be kept simple and clean, and still all the features are available where you would expect them. One important principle of Pimcore is single source publishing. That means that each information should be saved only once and then referenced to all the places where it's used. That means all the entities can be put into relation with each other, and so you can build up a knowledge graph with all the relation information. Relations itself are created via drag and drop, for example, like we have it here, this image, where we can just drag and drop the image to a document and Pimcore creates the relation in the backend. The Pimcore user interface can be highly customized. Right now we are logged in as an admin user, and of course the admin user sees all the features and all the options. You can reduce, adapt, customize the user interface with permissions and other concepts like custom views and perspectives. So the UI can be adapted for certain user groups and use cases, and you can optimize the user experience and make Pimcore and working with Pimcore good fun to its users.
This was a quick overview of the Pimcore backend interface. In the following courses, we will deep dive into all the features and functionalities we just saw, and many more. In addition to defining parent PHP classes, you also can define traits that should be integrated and injected into your class definition. Actually, it works the same way as with the parent PHP class. You need to define your trait in your IDE and add it to your project. and then specify the full qualified class name here in this use traits section. And once this is defined and you resave your class definition, then it will be added into the generated PHP class API, like this dirty indicator trait here with the additional traits that you defined here. The parent class definition and the trait definition is not only available for the class itself, but also for the listing classes, and works again exactly the same. So you just specify the fully qualified class name here, and then Pimcore will consider these settings while generating the PHP API. The first option of injecting custom functionality is a class definition setting, which can be defined for each class definition in the general settings, where you can define a so-called parent PHP class. And once a parent PHP class is defined, Pimcore makes sure that the generated PHP class for your class definition extends this parent PHP class that is defined at this point. To do so, let's just create such a parent PHP class, define it in some namespace, in some bundle. Doesn't need to be the app bundle, can be anywhere, but of course it needs to be loaded by Pimcore. Let's call it, for example, abstract test class. And this is a standard PHP class with one requirement. It needs to extend at some point in the class hierarchy the concrete data object implementation of Pimcore. This is necessary that Pimcore still can work with all the data objects, otherwise it will break. Other than that, you are completely free in terms of adding your custom functionality here. So we can, for example, add and get some custom functionality, whatever. And yeah, in this case, let's just return a random value between 1 and 10. And of course, you can add whatever methods you might need for your custom extensions. Then, of course, back in the class definitions, we need to define the parent PHP class. And once we save our class definition, then Pimcore regenerates the generated PHP class, the PHP API. And when we have a look at it, it's of course located under var classes data object test class. Then we see that this test class now extends our custom abstract test class. Now, of course, we can go back to our IDE and, for example, in some test controller action, load an instance of test class, and then, of course, also call all the getters and setters that we have defined in our custom abstract class. And yeah, when we go back to the controller, open up, then it prints out the random numbers that we generate in our custom functionality method.
Since Pimcore portals are standard Pimcore applications, they are also standard Symfony applications. And therefore we can utilize all the concepts Symfony provides for customizing applications. Let's have a look at the documentation and see what possibilities we have there.
The most important extension points are listed here in our development documentation. So, for example, we can easily override the Twig templates by using the standard Symfony way. And then we have additionally lots of different services we can override, like the name extractor, which defines which name should be visualized in the listings or in any relational fields for certain elements. We can override the main image extractor, which defines the preview image of elements. We can add additional data exporters, which define the format for the structured data download in the portal. We can add additional area bricks, We can add additional precondition services which allow us to further restrict the workspace definition of a data pool. And last but not least, we also have the possibility to listen to dozens of events which allow us to further customize and also of course extend the default behavior of a portal.
Not all front-end parts are implemented with classic Twig templates. The more client-oriented stuff, like the detail pages and the listing pages, is implemented with React. To customize the React parts, and not only the React parts but also all the styling stuff which is powered by Sass, you can set up a custom front-end build which allows you to override single JavaScript files and Sass files and adapt them to your needs. And this is how it's done.
Yeah, let's have a look at the documentation, because just watching the commands run is a bit boring. And so let's just quickly go through the steps we have here in our documentation. The first step is that we need to configure the certain customized frontend build in a configuration tree of Symfony, where we specify the name of the configuration of the build we want to set up. Then we need to make sure that Node.js is installed and set up our environment by running this portal engine update frontend build command. This command creates a package JSON in the root directory of our project and adds all the dependencies to it. Once this is finished, then we also need to run npm install to make sure that all the dependencies are installed properly. And then we are finished setting up our development environment and we can start our customizing work. For that, we create files and place it in a certain directory, which is the web portal engine, then the name of our customized frontend build, and then we use the same folder structure as we use in the core. So for example, styles, settings, variables, Sass for overwriting the variables Sass file. In this file then we can import the original one and overwrite all the stuff we want to overwrite. In this case, for example, just overwrite the primary color. This of course also can be done for JavaScript files, other Sass files, and so we can really customize all the things we need to customize. Then next step is to specify the customized frontend build in the portal settings. This can be done in the portal document here in the style settings, where we can choose the customized frontend build, and here a list of all the customized frontend builds appears that we have configured in the Symfony configuration tree settings. And as soon as this is done, we need to build, of course, our frontend build or run it. There we have two options. We can choose the development build, which has a watch included so that we can work on it continuously. And then as soon as we are finished, we should execute the development build and really make a build which is ready for the development. And then, yeah, we can use it and see our customizations directly in the portal.
One essence of Pimcore applications is that they are highly flexible and easily customizable. And this is not different with the Pimcore Experience portals. There are several ways for customizing the portals, like configuring the stylings, like overwriting existing services and adding new services to adapt the default behavior, and it's even possible to set up a custom frontend build to fully adapt the frontend to your needs. Let's start with the easiest and then step further to the more complicated options for customization.
The first and easiest option to customize a portal is to configure the styling directly here in the portal configuration. There we have a separate section where we can set certain colors, hex codes of the colors, and in addition to the colors we also can specify if we want to use the gradients for certain headers and modals and nav icons. And yeah, let's just change this a bit and also choose a different primary color here and also header color. Then we save the document, and to apply the changes we need to update the frontend build here. And as soon as this is done, we can go back to our portal, reload, and see that we have already a different styling for our portal. These quite simple settings already allow you quite extensively customize the styling of the portal. And This is really easy because you just need to specify the settings here directly in the document.
Relations are an important part of every data model. They allow you to describe the dependencies between the elements of the data model, put them into relation with each other, and so set up a whole knowledge graph for your application. As we already saw, also within Pimcore you can define relations. You can put data objects into relation with other data objects, with documents, with assets. You can put any data element of Pimcore into relation with another data element. In the context of the data objects, there are a couple of data types that allow you to define relations. Let's discuss them and start with the simple ones.
The simplest relation type is the many-to-one relation, which allows you to create a relation to exactly one other element. In the specific settings, you can define which element that can be. You can specify that you allow documents, that you allow assets, that you allow data objects. And for each of these major types, you also can restrict to subtypes. So for example, just allow images or just allow relations to data objects of a certain data object class, for example, to category objects. And when we open up our sample object, then we can create the relation either via drag and drop or via opening up the search dialog and selecting the element that we want to relate to. The same, but not only relating to one element, but to many elements, is the many-to-many relation. So this allows you to create relations to multiple other elements. Same as for the many-to-one relation, you can restrict either to documents, to assets, or to data objects, and also again define the subtypes. For example, allow relations to only category objects. And assigning the relation is again the same as for the many-to-one relation, so either by drag and drop or opening up the search dialog, and now we can select multiple elements that we want to relate to. In addition to the many-to-many data object type, we have another one which is a bit more specific, which is called the many-to-many object relation. And the many-to-many object relation is a more specific implementation of the many-to-many relation, which only allows data objects as related items. Again, we can specify which data object class we want to allow here as the related items. And in addition to the data object classes, we also can specify the visible fields in the grid of the data relation. So for example, we just want to show the ID, the key, and the name of the related items in our relation grid. And then in addition to that, we also can allow the creation of new data objects directly in the relation field. Let's see how this looks like. Let's go back to our data object. And there we see the additional categories field here. Again, we can assign the relations via drag and drop or via opening up the search dialog and selecting the related items. And what we already see here is that we have now not the default data shown in the grid here, like ID, reference, type, and subtype, but we have shown the attributes that we specified in the class definitions, which are the ID, the key, and the name of the related objects. Then we have also this plus button here, which allows us to create new data objects directly in this relation field here and relate these new data fields right away to this relation field. In addition to the creation of new objects, we have another option which we can activate here, which is this enable asynchronous loading in admin. And this is a performance improvement in terms of the loading of the data objects, which is especially useful when you have hundreds or thousands related elements in such a relation field, because having these many relations might slow down the loading of the data object, because all the relations have to be loaded during the loading of the data object. And when you activate this option here, then the elements are only loaded when the relation field is rendered. That means the data object opens up right away, the all the relations don't have to be loaded at the loading of the data object. And when you have this relation field in a tab which is not rendered right away when you open up the data object, then the related items are loaded only when the tab is opened and rendered. In addition to the simple many-to-many relations, we also have advanced many-to-many relations. The advanced many-to-many relations allow us to store additional information directly onto the relation itself. For example, we have customers. These customers have interests, and these interests have different relevance to the customer. So one interest is more relevant than the other, and if we want to store this information onto the relation, we can use the advanced many-to-many relations. Again, we have advanced many-to-many relation and advanced many-to-many object relation. The advanced many-to-many object relation is again a more specific implementation that only allows data object as relation objects and also allows us to specify the visible fields. Let's start with the advanced many-to-many relation and implement this interest example. So we now need to imagine that this data object class is a customer and has relations to interests. Again, we can specify which relations we want to allow. For example, we allow data objects of the type customer segment. And then we can specify the additional information we want to store directly on the relation. For example, we store a weight, which should store the relevance of the relation. And of course, we also can add additional data attributes we want to store on the relation. And we can select from a couple of simple data types here, like number, text, select, and boolean. Let's save that and just reload our data object here. And there we see again we have an additional data attribute for relations, and again we can just drag and drop the data objects and create the relation between these data objects. And besides just adding the relation, we also can specify these additional attributes here, like for example the weight, and so specify that the full size is much more relevant than the grand tour. Then we have some additional information or options we can specify here. We can enable the batch edit for the columns we specified here, so we can batch edit the information here. We can allow multiple assignments, which is sometimes quite handy, so that I can assign one and the same data object or one and the same asset document multiple times to the relation field and add different additional metadata to it. And then we also have here this option, enable async load in the admin interface to improve the loading performance in the admin interface. The advanced many-to-many object relation is pretty similar. Again, we just can specify data object classes. Here in this case, we only can specify one class. We have the visible fields again that we can specify, and the rest is the same as with the many-to-many relation here, as I can specify the columns of the additional information, and I also have these three options here to enable batch edit, to allow multiple assignments, and to enable the asynchronous loading.
In the relational data types, there is also one additional data type we need to address at least shortly, and this is the so-called reverse many-to-many relation data type. This data type is a bit special because it is actually not a really data type, it's only a convenience function for the Pimcore backend interface and has no implication to the storage of the database and also no implications to the actual PHP API. So actually there's no getter generated for this data attribute. This can be used, for example, in this use case where we have an article and blog categories, and the article has a many-to-many relation to the blog category, and the reverse many-to-many object relation now can be used to visualize all the articles that have the certain category assigned. Let's just modify this or define this here, and then it should be pretty clear. So there we define, let's see all the relations that are defined in the blog article class in the categories field. And once we have defined this and open up our blog categories, then we see a list of all the articles that have assigned this category here. Of course, we can follow this relation here. And what we also can do at this point is that we can assign additional ones. So we just assign additional attributes here. But now what happens is when I save this object here, that also the original object, in this case this category, this article object, gets updated and has this additional category assigned now. As I said before, this is only some kind of convenient functionality for the Pimcore admin interface. It has no implications on the database or the data storage itself, and it also has no implications on the PHP API. That means there is no getter generated that gives us all the articles of a certain blog category.
Last but not least, we need to discuss about the REST API that is shipped with the CMF. It provides you a simple way of working with customer data via REST endpoints. This concludes the customer data itself, as well as the activities and also the customer segments. So it's, for example, easily possible to track an activity for a certain customer via the REST endpoints. And so you can, for example, connect multiple systems and position Pimcore as the central data lake for all the customer interaction tracking.
The REST API is based on Pimcore's REST API and provides additional endpoints as listed here in our documentation. Let's quickly test two of them. First of all, loading customer data, which is just CMF customers and then the ID of the customer. And as the REST API is based on the Pimcore REST API, we also need to provide the API token that is based on a Pimcore user. And when we execute this, we get the customer data of the desired customer here with all the data attributes and also with the segments, for example. Next, for example, let's just track some activities. For that, we change the endpoint to post CMF activities. And we then, of course, need to provide some post information where we want to track an activity of the REST type to the customer with the ID 1018 with some additional attributes. And when we now run this again, we get a success response code here. And when we open the customer and see his activities again, we see that we tracked an additional activity with also some additional data attributes here.
Hello and welcome to this session of Pimcore Insights. This time it's all about URLs and routing. Routing defines which controller action is responsible for handling a certain request, and therefore it's quite an important part of every web application. Pimcore routing is based on Symfony routing, and in addition to all the functionality that is provided by the Symfony framework, Pimcore adds a couple of additional options to the routing process. That means for every request that is processed by Pimcore, following list of possible routing definitions is checked.
First in the list are Symfony routes. That means Pimcore first checks if there is any Symfony route that matches the current request and executes the controller action of this defined route here. The Symfony routes are the standard Symfony routes as provided by the Symfony framework. That means you can configure them in annotations or in the configuration files, and you of course can use all the Symfony tools that are provided, like for example the debug router command, to see which routes are configured in the current setup. As you can see there also is that all the system admin interface URLs and also the REST API URLs are defined via Symfony routes, and that's the reason why the first priority point here says Symfony and system routes. Second in the list are redirects with priority 99, and these redirects can be configured directly within the Pimcore admin interface in this redirects menu, and there you can specify redirects that should redirect from some URL to another URL, for example to a document. Besides the URLs, you also can limit the redirects to certain sites and can specify additional options like the HTTP status, or whether the source is a regex that should be validated, or for example an expiry date. And then you also can specify a priority of this redirect, and when you set this priority to 99, then this redirect is checked second in the list when Pimcore processes a request. Be aware that setting redirects with priority 99 can have severe effects on the performance of the entire application, since these redirects need to be validated for many requests that are processed by Pimcore. Third in the list are Pimcore documents and pretty URLs. That means if there is no Symfony route and there is no redirect with priority 99 that matches the current request, then Pimcore checks if there is a document or a pretty URL that matches the request. The URLs of documents are based on the tree, of course, as we already discussed, and the pretty URLs of each document can be configured directly within the Pimcore document in this configuration option here. Fourth in the list are URL slugs of data objects. As discussed in one of the courses of data objects, there is a special data type for data objects which is called URL slug, and this data type allows you to define URL slugs for data objects. Of course, these URL slugs have to be unique, and these URL slugs are evaluated in the fourth priority when Pimcore processes a request. Next in the list are static routes or custom routes. Static routes are a Pimcore feature that is very similar to the Symfony routes and allows you to define routes directly within the Pimcore admin interface. And this can be done here in this static routes menu, and there you can specify static routes that need to have a name, that need to have a pattern which is matched against the request, and once the pattern matches to the request, then the bundle, controller and action that is configured here is executed. In addition, you can specify a reverse pattern which then can be used to create URLs based on this reverse pattern and the given variables to build up the URLs in your controller code, for example. One important difference between the static routes and the Symfony routes is that the static routes can be limited to certain sites. That means that these static routes only apply if a request comes through a certain site. If also no static route matches the request, the redirects are checked again. Now all the redirects that have a priority lower than 99, and if one or more of these redirects match the request, then they are executed based on their priority.
It's quite important to know this priority list because this might have some side effects and some behavior that might be strange at the first place, but if you know this priority list, it's quite self-explaining. For example, let's just define a new action in our controller. Let's make it a test action that returns just a simple response. Let's just make oh no, and define a Symfony route for that controller action. And this Symfony route, we coincidentally make the same pattern as a document path. For example, en introduction. And now, if we go back to Pimcore backend and open up our introduction document, which has actually the path en introduction, of course, this document has some content that was edited by the editor, but when we reload this now, we see that now not the actual document content is delivered, but the route that we just defined as a Symfony route is used because, of course, it has higher priority. So it's just important to know that there are these priorities, and then a lot of maybe strange behavior is quite self-explaining and quite obvious. There are two options for configuring permissions within the workflow configuration. First option is to define so-called transition guards, which configure or define which transitions are allowed for certain users and also in certain states of, for example, a data object. And the second option is that you can configure permissions in places which define which information can or should be shown to the users in a certain place, or which actions like saving, deleting, unpublishing, publishing the elements is allowed in a certain place. Let's start with the guards of the transitions, which are just an option here in the transition definition. And with these guards, you actually can configure a Symfony expression where you can specify and check for certain environment things, and also directly for options or data or states of the element itself. For example, you can check that an action is only allowed, or a transition is only allowed when you have really a logged in user. You can check for users that have a certain role. Actually, this is the equivalent to the Pimcore user role in the Pimcore admin interface. There is also one wildcard or one special role for the Pimcore admin users, which is Pimcore admin in this case. And then you also have access to the element itself of the workflow and can call getters on it and check the values for certain values. Once you have defined this guard, you only can execute the transitions when all the criteria from this guard is applied. And this not only applies for the Pimcore admin, but also when you try to execute the transition via the Pimcore API. That means, for example, if you just have a command that is executing a certain transition and you have this guard here specified, then this won't be possible because a command normally don't have a specified Pimcore admin user session. In addition to this guard definition directly in the configuration, you of course also can use the guard events that are fired by the Symfony workflow module to allow or prevent certain transitions if you have a more custom, a more specialized, a more complex guard implementation that you need to integrate into your workflow. The second option to define permissions within a Pimcore workflow configuration is a much more Pimcore specific thing. This allows you to specify permissions for places which define permissions that apply to the element when it's in a certain place. And for that you can add a permission node to each place configuration, which looks like the following. You have this permissions node here, and then you define an array of options that apply. You can define multiple array entries in this case, and each of these array entries has to have one condition, which is again a Symfony expression where you can specify to which users this permission setting apply. In our case, this permission setting applies to all users that have the role editor. And then I can configure certain permission configurations like the typical Pimcore permission settings, like publish, like save, like delete, like unpublish. So I can specify all the options that a user should have in terms of updating and saving and publishing the element. And in addition to that, you also can specify, at least for data objects, which custom layout should be used when an element is in a certain place. The custom layout configuration is just object layout, and then you provide the identifier of the layout that should be used in this workflow place. Another quite powerful configuration option are the so-called marking stores. The marking stores define how the place information of each element of a workflow is stored to any persistence. By default, Pimcore uses the so-called state table marking store, which uses an additional table that stores all the state or place information of each element for each workflow. In addition to this default marking store, there are a couple of additional marking stores available, some of which ship directly with the Symfony framework, like the single state and the multiple state workflow, and some of which are quite Pimcore specific, like the data object multiple state and the data object split state marking store. All these 4 additional marking stores use actually setters or getters from the actual workflow element to store the place information. Like in the case of data objects, they use a data attribute like input field or a select field, or maybe a multi-select field for storing all the place information. Important to know is that the multiple state cannot be used in combination with the multi-select data object fields. If you want to specify a multi-select field in your data object to store the place information, then you have to use the Pimcore specific data object multiple state store. In addition to these additional marking stores, Pimcore also provides you a specific options provider when you're using select or multi-select fields, that you can specify all the places that are configured for a certain workflow, and so you don't have to care about the class definition and the correct place setup here in this class definition. To do so, let's just start with a quick example and use our existing workflow and specify the marking store for storing the information in the class editor or in the data object. So let's go to the class editor and add, for example, an additional multi-select field, which we call, for example, training workflow state. As option provider, here we provide this service here that is registered automatically by Pimcore, and as options provider data, we need to provide the workflow key here, and that's actually already about it when it comes for the class definition. And to set up the workflow configuration, we have to configure, of course, this marking store now to our workflow configuration. And for that, we need to use the marking store node. We need to specify the type, which is in our case the data object multiple state, and as the argument, we need to use the field name of our multi-select field. And once that is done, we can switch back to our Pimcore admin interface and start all over the workflow again. And when we then have a look at our data objects attribute here, we see that the place information now is stored directly in the data object. And this, of course, provides you some additional options when it comes for reporting, for filtering data, for exporting data, because you can use all the standard Pimcore APIs and Pimcore functionality like the grids and all these kind of things. Let's have a look at the most important configuration options and set up a simple demo workflow. I already have prepared a simple workflow, which will look like this, where we have one starting place, then we have a transition that results in two places in parallel, and then we have again some transitions to forward these streams of the workflow, and at the end then we have again one transition that collects the two streams again to one final place of the workflow. To have a look at the configuration, let's just switch in our IDE, and there we see the workflow configuration for exactly this workflow we have just visualized. And there we see we have this Pimcore workflows node in our configuration tree, and there we can configure multiple workflows. Each workflow has to have one unique name, which is the key of the workflow, and then I have all the options available that one workflow can have, like for example a label, which is just a nice name of the workflow. It's in this case not mandatory. If no label is set, then it takes the workflow key. Then we have the supports section, which configures which elements are relevant for this workflow, so for which elements this workflow is configured. In our case, we have just configured the workflow for the data object product. The next thing we configure are the places, where we at least need to specify, of course, the key of the place. Then we can configure a nice looking label, which is also then visualized in the Pimcore admin interface. And there are also a couple of additional things. We'll have a look at a few of them later on. One nice to have feature is that we also can configure a color, which is then also again used for visualization in the Pimcore backend. Then, last but not least, we have the possibility to configure all the transitions that are available. And right now we have also the minimum configuration for the transitions. So again, we have to configure a key. Then we have to configure from which place this transition should be possible. And we have, of course, to configure the places that the transition should put the element into. Once we have configured this workflow, the Pimcore user interface looks as follows. We first of all have here an additional tab, which is the workflow tab, which visualizes all the workflows that are configured for the current element, and also gives you the current state information, which means it visualizes the current place and also visualizes the workflow graph with the highlighted place that the element is currently in. And in addition to this workflow tab, we also have some information here up in the toolbar where we first of all have place information of the current workflows and the current places of these workflows. You can configure which place information should be visualized up there and which is not. And then you have this actions menu, which lists you all the transitions that are currently possible for you as a user and in the current state of your Pimcore element. And by just clicking on these transitions, then the workflow is executed, the transition is executed, and the element then again, for example, is in the next places. And this is already the most important configuration part of the workflows. You can, of course, configure multiple workflows, and of course, there are a few advanced options we'll have a look at right now. All the configuration options you can find, of course, in our documentation and also, of course, in the dump reference command of the Pimcore Symfony console, which actually prints out all this information that we also have here in our documentation. And we all tried to document it directly inline in the dump reference and describe all the workflow options that are available here. Let's just have a look at a few additional ones here. Of course, you can enable or disable the workflow if you want to. You can specify priorities of multiple workflows. You can, for example, specify the type of the workflow, which is either workflow or state machine. By default, if you don't define anything, it's a workflow. This is also the reason why our workflow configuration can have multiple places in parallel. And another quite important or sometimes quite important thing is that besides the support configuration, you also can use the support strategy configuration, which allow you a more fine-grained and a more specific definition which elements should be part of the workflow and which elements should not be part.
Another quite interesting and often requested data type is the URL slug data type. The URL slug data type allows you to define URL slugs for data objects and specify the controller action that should be executed when a request of a corresponding URL is processed. Let's have a look at our demo application where we also have some examples for this URL slug data type. For example, in our car class, where we have this URL slug defined here, and there we have then specified the controller action that should be executed. As you can see there already, it's possible to define multiple URL slugs per data object class, so you can also specify multiple URL slugs for each data object. When we open up a data object, then we see that we can specify here the URL slug for this corresponding data object, and we also can specify a URL slug per site that is specified or configured in the current system. In the controller action then we have a couple of parameters available. Besides the request that is injected, we have the data object available. For that the URL was opened, and we also have the URL slug data here. The URL slugs are stored in a separate database table, which is the object URLs slugs table, and there we have all the information, of course, available, like the object ID, the class ID, the field name, index, owner type, these kind of things, and of course then we also have the slug available here. The slug, of course, needs to be unique, and this table is also used while the routing process, while checking if a certain request matches any of these slugs defined here. URL slugs are checked in 4th priority while routing, after the Symfony routes, after the redirects with priority 99, and after the documents. Long story short, the URL slug data type allows you to specify custom URLs for data objects, like for products, like for special blog entries, events, or whatsoever.
Another data type that is worth mentioning is the so-called encrypted field data type, which allows you to store some data in an encrypted way. The encrypted data field can have different data types. Most simple data types are supported at this point, and this encrypted field is then stored in an encrypted way on the database. And when you call the getter, you decrypt the data again and can work with the data normally. This means that if some attack hits your database, the data is still encrypted and cannot be decrypted unless you get the key, which is stored somewhere on the file system in the storage of your Pimcore application. A consequence of encrypting the data on database is, of course, that you have certain performance impacts, and the second thing is that you cannot query or filter for the data since the data is stored in an encrypted way in the database. In addition to add encrypted fields, there is another option to store encrypted data on the database, which is a class setting, which allows you to store all the data in an encrypted way and use the data addressed table-based encryption for MySQL. This, of course, needs to be enabled and available on your database server, as this command here suggests. But once this is activated, then all the data is stored in an encrypted way on the database. Of course, this also has certain performance impacts on your application. Another quite powerful data type is the so-called calculated value data type, which is, as the name already suggests, a data type that allows you to calculate some values, and this can be defined with the definition of a so-called calculator class, which is a PHP class that you need to implement within your application and then define the name here. The calculator class needs to implement the compute method, has access to the object itself and to some context information, for example, whether this current field is located in field collection or in localized fields or something like that. And the compute method then, of course, can calculate whatever you implement there. It can be a simple sum of two values or to multiply simple values, or it can be a bit more complex, for example, to calculate the data quality or the filling state, the data completeness of certain data objects or attributes. So whatever you're using this calculated fields for, you can calculate pretty much anything within this. The calculated value, of course, is not stored in the database since it's calculated on the fly when you, for example, open up the data object in the Pimcore backend, or if you call the getter in the PHP API or the web service API, but the data is stored in the query table every time when you update or save the data object, which means that it's possible to filter for the data. So there we have this some value column in our query table. And yeah, at this point you need to be a bit careful because in the query table, of course, there is not the most current value, but only the value when you saved the data object the last time. So on every save, the value is updated, but of course the value could change due to some external resources, to some external data sources. And if your calculation depends on these external data sources, then the value in the query table might be an old value because, as I said before, it's only updated when you save the data object. These two simple examples should give you an impression of how to start and how to work with the Pimcore e-commerce framework. It always follows the same principles and the same scheme. For further details, also have a look at our documentation and our demo application. In general, this demo application can be seen as a reference of how things can be done and can be implemented within Pimcore and within the Pimcore e-commerce framework. The structure table is, as the name already suggests, a bit more structured, and that means that you have to define which rows and columns should be available already in the class definition. And that means basically you build up a matrix, and there you can define different rows and columns. Let's just define, for example, different rows like child and adult, and in the column section we define, for example, 1 day and 2 day, and so we can build up a matrix for example, prices here, and so we define also the data type of the cells, which can be a number, a text, or a checkbox. And once we have defined that, let's switch back to our data object here. There we see we have our matrix with the fixed rows and the fixed columns here, and where I can just enter all the data directly in the cells. Another difference between the structured table and the normal table is that on database level, the structured table is stored the way that each cell in the matrix has a separate database column, which of course makes it easily possible to filter and search for the data again. So there we see our matrix column or attribute, which has actually 4 columns, since we have 4 cells in our matrix, where we have all the combinations of all the rows and columns. There are 2 data types left in the structured section, which is the table and the structured table. The table is really just a very simple table where you can specify rows and columns, and if these rows and these columns should be fixed or not. But other than that, you cannot specify or restrict anything. So the editor has complete freedom in terms of inserting the data, adding additional columns to the data, adding additional rows to the data attribute, and also specifying the content within it. On database level, this table data type is just serialized and stored into one database column of the data object. So querying for the data or filtering for the data is also quite complex, or well, not really possible. Let's just open up the database table here. We see here the table column, and when we have a look at the data, we see that the table is just a serialized PHP object.
In terms of the technical details, there are a couple of things important to know about. First of all, as already mentioned, the enterprise asset metadata do not replace the standard asset metadata. They are built on top of them. Second, this is also valid for the persistence, as the enterprise asset metadata use the existing infrastructure for persisting all the metadata information. And last but not least, also the enterprise metadata can be managed via an API. Let's have a look how this works.
The API is pretty simple and is described here in the documentation. Maybe let's start with managing the asset metadata itself, so the metadata attributes, because they stay the same as we know them already from the standard metadata. So we have some methods directly on the asset object like add metadata or set metadata, and so we can apply all the different metadata that we want to have applied to the asset. And then the second thing we need to consider is that we want to define what collections should be added to the asset. And this can be done with an helper model, which is called collections. And these collections can have an asset ID and then a list of collections where you add the collections by their name. And then you actually have two methods how you can apply them to the asset. The first one is apply to asset. This one applies the assigned collections to the asset, but does not save the asset itself. So this can be used if I save the asset later on anyway. And the second method is a save method on this collections model, and this one applies the defined collections to the asset and saves the asset too. Besides creating a new collection for this assigning, there is also the possibility to get the collection based on an asset ID. So there is a get by ID static methods to this collection model where we can load existing collections from an asset. The next aspect we need to discuss is which file types are supported and where the actual files are written to. And these settings can be done in this delivery destination tab of the configuration. The first thing is the file type, where we can choose from CSV, XML, and JSON. And all these three types generate flat files. That means also XML and JSON files are just one-dimensional, simple files and not any multi-dimensional files, which are currently not supported by this adapter. The file types can be extended with additional types. We will discuss this in the next session. Then next is that we define the file name, where we just write in the name that the file should have. And there it's important to know that the file name also can contain placeholders known from string format time, so that we can create date time aware file names, which is sometimes quite handy. Once we have defined the file type, we also need to define where we want to put the files. And there we have to decide or specify two things. First of all, we need to specify what should happen when we have a file name conflict. There again, we have three options. We have the override option, which just overrides the existing file name. Then we have the automatic file increment, which just increments the file name with underline 1, 2, 3, 4, 5 or whatsoever, and so creates a new file. And then we have the update current file option, which tries to update the current file. If we choose this option, it's important that we have the ID in our schema definition, because the ID is the identifier based on what the data records are identified and then are updated. So there we really can create an up-to-date file and also just update all the elements that changed in an existing file. And then besides the file name conflict, we also can specify the delivery type, and there we also have three types available. We can write the files to a local directory on the server, and there we have to specify the directory relative to the project root folder. Second option is an SFTP upload, where we can upload the files to any SFTP remote location with the SFTP protocol. There we have all the settings available that we need to specify that we can upload this to the SFTP remote location. And last but not least, we also have the possibility to make an HTTP push to a remote location where we post or put the file to any web server, and then it's processed on this web server then. Once all the items are pre-calculated and in the cache, they are ready to be delivered to ProductsUp with the delivery endpoint. And as soon as you have set this up on product subside, you normally don't need to care about this anymore because all of it takes place automatically. If for whatever reason you want to debug and see what data is exported to product sub, you can use this URL here and see what data is exported from Pimcore. When you are logged into Pimcore, you also don't need to provide the security token, so you just can open up this URL here, and there you see all the data that is exported with all the different data attributes that are defined. You also see how we deliver the asset data. We just deliver a URL to the asset, either to the thumbnail if defined or to the original asset. And yeah, so are all the items exported to product sub. This endpoint actually also provides a couple of get parameters. It provides a page parameter to define what page, and also a per page parameter to define how many items should be exported per page. And then we also have a parameter which is called since modification date, which filters us for a certain modification date and helps us to not need to export all the items all the time, but only certain items from a certain point of time. There is one more special aspect of the index worth mentioning, and that is about the tree hierarchy management. In the simple REST API, there is a call for navigating through the tree hierarchy of the data. And for that, it is also necessary to index the tree information. Now with the configuration, we have the possibility to configure quite sophisticated workspaces and do something like that we exclude one folder and then explicitly include one subfolder of it. Now the indexing always tries to build up a valid tree without any missing pieces in the index, and in that case it means that the dev example folders will be still in the index, but just as a folder with only the sub items that are explicitly included, like this features folder here. And all the other items of the dev example folders, like properties and this thumbnails screenshot here, will be not included in the index. To make sure to have a valid tree in the index, it might be necessary to process certain items multiple times or add additional items to the process queue. And that is the reason why it happens that the queue might not be empty after the process queue command was executed.
In terms of the technical insights, there is one aspect important to know about. The direct edit feature needs a server-side part and a client-side part to work. The server-side part is responsible for providing the data and applying the changes back to the Pimcore assets. And the client-side part is a desktop application that needs to be installed and is responsible for downloading the data, opening the editor, and uploading the changes back to Pimcore. Let's start with the server-side part.
The server-side part of the direct edit feature is a standard Pimcore bundle. That means we can download it via Composer, we can install it with the standard Pimcore commands, Pimcore bundle enable and Pimcore bundle install. And in addition to the install command, we also need to run the doctrine schema update command, which updates the database scheme and adds the necessary database table. Then, in addition to the standard setup, there is one more thing we need to consider during the configuration and setup, which has something to do with this status window, which appears as soon as we start the editing process and which is also updated as soon as we do any changes here and save them and upload them back. And these updates of this window here are implemented with a server-client communication based on Mercure. And for that, of course, we need to make sure that Mercure is set up properly and running on the system. And for that, we need to follow the steps we have listed here in the documentation. So, for example, we need to set up a reverse proxy on the web server, need to specify a GWT key in the parameters. Then we need to start the Mercure and also, of course, make sure that the Mercure is running properly. And this can be easily checked by just calling this URL here and seeing if the response is something like this missing topic parameter here. So this says that Mercure is running and reachable and we are ready to go. Important thing is that the Mercure also needs to be reachable from the server side. So you also need to make sure that you can open up the same URL on your server and that you have proper DNS entries there. And yeah, as soon as you have this all set up, then you're ready to go and can start with the direct edit feature.
In terms of the technical details, there are a couple of things important to know about. First, we need to discuss when the data is written into the files. Second, we will have a look at the supported file types and where the files are written to. And last but not least, we also will have a look at the options to extend the Data Hub adapter.
Let's start with the first aspect, which is when the actual files are written, and this can be defined with this trigger for delivery setting. There we have three options, and let's have a detailed look at all of them. The first option is disabled, which means that the files are never written automatically. So nevertheless, if a data object is saved or so, the files are not written automatically, and we need to execute a command in the background on a regular basis who then creates the files. Second option is deliver directly on save, which, as the name already says, creates the files directly every time a data object is saved. And at this point, it's important to know that not only the data object itself is added to the export file, but also all the sub-items if data inheritance is activated. And the third option is populate to queue, which is similar to the directly on save, but it don't create the export file, it just adds the items to a queue, and then a command in the background needs to be executed which processes this queue and creates an export file based on this queue. In a real-life scenario, you most likely will have disabled or populate to queue, because this deliver directly on save can have influence on your saving performance, as the calculations for the schema might be quite complex and would be executed every time you save a data object, and especially if you also have the inheritance activated and huge inheritance trees, this could result in a very big operation and a very big export file. So typically you will have disabled or populate to queue. Let's have a look at the command which is executed in the background, which is the Data Hub export file command. And this Data Hub export file command has a couple of options you can set, and maybe the most important one, or there's only one very important one, which is this only queue items, which specifies if the command should only process the export queue, or if the command should make a full export, which exports all the data that is defined with the workspace. In addition to this only queue items command, there is also a second option, which is the config ID, which is optional and where you can specify which export configuration should be actually executed. If this is not provided, this setting, then all the configurations for file export are executed with this Data Hub export file command.
In terms of the technical details, there are two important things to know about. First, the data is not delivered directly to Products Hub, it's written to a cache on Pimcore side and then delivered from there. And second, for the delivery, Pimcore provides an endpoint where Products Hub can load the data into their system. Let's start with the first one.
The cache contains all the export items which are pre-calculated once they are changed, instead of calculating them every time when Products uploads the data. So this cache helps us to make the integration more robust and allows Products Hub to import the data with high speed without creating a huge load on the Pimcore side. With this knowledge, also this trigger for delivery settings now makes more sense, as it specifies when this cache should be updated and provides us three different options. First option is to disable an automatic update of the cache. That means it needs to be updated manually by running a command. We have a look at this command in a second, but first let's have a look at the other two options there. Second option is deliver directly on save. That means every time a data object is saved, which is in the workspace definition, then the cache is updated directly right away. And the third option is to populate to queue. That means every time the data object is saved, it's added to a queue, and then a command needs to be run in the background which processes this queue and reads all the items from the queue and updates the cache entries for these items. In a real-life scenario, most likely we will have set the setting to either disabled or populate to queue, because when you set it to delivery directly on save, every time you save a data object, it needs to be updated also to the cache, and depending on your schema definition, this might include some extensive calculation of the data and so has some influence on the saving performance of your system. But of course, it depends on your system, on your setup, and on your use cases. So for disabled and populate to queue, we need to have a command in the background, and let's have a look at this command, which is the data hub export product sub command. And this command helps us to update the cache table and has two important options we need to discuss about. The first option is this only queue items flag here, which decides whether the command should process all the items that are in the workspace, which is used when you have the trigger to disabled. Or if you set this only queue items, then the command only processes the items that are in the queue and updates only these items to the cache. And the second important option is then the processes option here. You can specify this allows you to run multiple parallel processes and so speed up the calculation of the cache items. This command can be executed, of course, as a cron job on the operating system level, or as an alternative, you also can use tools like the process manager, where you can set up this command, execute it manually, or also set it up to a cron job, of course, and also have all this process log available here, where you see what's going on and what data is exported. The data is then actually written into a table, a cache table, which is the data hub product sub cache item table. And there you see it's really just a cache table where all the data is serialized as a JSON directly into this table, and all the data is updated there. Finally, it's time to have a look at the calls of the endpoint. And for that, we open up the Swagger UI, as this provides us a nice UI for the endpoint, where it lists all the available calls, also lists us all the available parameters, and it also lets us execute the calls. Let's have first a quick overview of the calls that are available. The first one is the tree items call, which allows to navigate through the tree hierarchy of all the items that are available in the endpoint, based on the Pimcore folder structure. The second one is a search call, which, as the name already says, allows us to search for items in the endpoint. And the third one is a get element by ID call, which allows us to get a single element by its ID. Let's maybe start with the tree items call and also execute this. And for this, we need to authorize ourselves first. For that, we use the API key here. And then we open up the tree items call and let's try it out. First parameter that is required is the configuration name, which is in our case the frontend app here. Then we can specify if we want to navigate through the asset tree or through the object tree. Let's go for the assets. And then we specify a parent ID. In our case, we define 1, and then let's maybe just execute it once. And there we see our response here, where we have a couple of folders available, which are the car images folder, which is the sample content folder. And then we also have all the available labels with the nice names, as we don't have defined any nice names in the configuration. It's just the keys themselves that are provided here. So let's maybe dig a bit deeper into the first level here and use a different parent ID. Now let's just jump into the car images folder. And there we see again we have some subfolders here available. And let's maybe also jump into the first subfolder here, which is the Jaguar folder with the ID 5. And then finally we also have reached some actual assets here, where we have all the asset data available with some system attributes, with all the metadata attributes, and additional attributes like dimensions data, like SF data, and these kind of things. And finally we also have the binary data, where we have the paths to all the thumbnails that we configured and to the original assets if we have activated it. So let's maybe have a look at the other parameters we have available here. We can include or exclude the folders of a certain level. We can specify the size. Let's maybe reduce that to 1. We can specify a full text search term that is used for filtering the results of the current level. We have also the possibility to further filter it down. For that we use a specific syntax, which we also used for the old Pimcore REST web services. Then we have the option to define an order by. We have a paging possibility, and last but not least, we also can include aggregations here. Let's maybe just include the aggregations to see what they actually do. And as soon as we have activated these aggregations, we have an additional node in our response here, where we see all the different attributes that we have activated in our configuration. And then we have all the buckets, which are all the possible values of this corresponding attribute here. And we also have an element count that tells us how many items have this specific value. And this is for all the attributes we have activated. So in our case, we have activated the width, the height, and we have also defined some system attributes like the type itself. And then we have some additional metadata attributes, like for example the author here. And the aggregation result lists us all the authors and also the document count or the element count of the corresponding author. This information then can be used to build up any layered navigations in your front-end application, and of course also can be used then for constructing here filter definitions and filtering down the results. The next endpoint then is the search endpoint, which is, as I already said, an endpoint for searching. Again, we need to define a config ID. We have the possibility to specify the response size. We have, of course, the possibility to provide a full text search term, a filter term, ordering specific, and the paging. And then we also here have again the possibility to define if we want to include the aggregations or not. The difference between the search call and the tree items call is that for the search call we don't get any folders, we don't have any hierarchy, we just have a flat result of any elements that fulfill the search term and the filter criteria. So there in the response we have assets and data objects mixed up and have all the results in the result that match the search criteria. So for example, there we have a data object now in the response, and above we had assets in the result. And then last but not least, let's just go for the last call here, which is the get element call. And this one here is again has the parameter for the config. Then we need to decide if we want to use an asset or data object, and then we provide the ID. For example, let's just provide the ID 9, and then we get as a result the single element with the corresponding ID as the response. The client is an Electron application that needs to be installed on every system where you want to use this direct edit feature. It supports Windows and macOS systems, and there it registers for a certain protocol, and that means as soon as a browser opens a link of this protocol, the client is started automatically and takes over the whole client-side communication. That means downloading the asset data, opening the local editor, watching for local changes, and then uploading the changes back to Pimcore. In addition to that, it also provides a system try icon with a context menu where we have a couple of debugging possibilities. First one is a list of all the current direct edits. That means you can have multiple direct edits in parallel active, and there you have a list of all of them and the status information. The second entry is opening the local temporary directory where all the data is stored from the client, so where the client downloads the data to, and where also the editors then do the changes and save their changes. And the third entry of this context menu shows the log directory where the client stores all the log information, which is sometimes quite useful when you're trying to figuring out what's going on and what's going wrong. Normally you don't need that, and the client really runs very transparent to the user and does all its magic in the background. The last aspect we need to discuss is how we can customize and extend the file export adapter. Actually, there are a couple of ways of doing so, and it's possible to really extensively customize the file export adapter. The first option we have is to add additional transmitters. Transmitters are the services who are responsible to put the export file to its desired destination, like we have it here for HTTP, SFTP upload or local directory. And to add additional entries here in this list, you just need to create a custom service that extends the abstract transmitter class. We need to register it as a service and add this transmitter tag to it. And then in addition to that, we also need to add a JavaScript component to it, which defines the custom input fields that might be necessary. And if there are no input fields necessary, we just need to provide an empty function for that the whole mechanism works. Second option is that we can add additional exporter types. Exporter types are the types of the file, like the CSV, XML, and JSON we have right now. And to add additional ones there, we just need to add an additional service which extends the abstract exporter class, and then register the service again with a certain tag, which is the exporter type tab. Besides adding types and transmitters, it's also possible to customize the existing ones. For that, we just need to override the service definitions for the existing ones and provide our custom implementations for that. Then it's also possible to implement certain event listeners. So there are a couple of events fired in the whole export process, and so with event listeners we can customize these processes and adapt to our needs. And if all that is not enough, there is even one more possibility, which is overwriting the whole export service itself. This export service controls and implements the whole export service, and so gives you full control of everything that happens. And there are two options how you can overwrite this one, or two places where you can configure that you want to overwrite it. First of all, there is a Symfony configuration tree configuration that defines the service that should be used for this exporter. By changing this configuration, you can globally override the exporter service and point it to your custom implementation. And in addition to this global configuration, you also can specify the exporter per configuration. And there you can add this custom export service where you just provide the service ID, and then for just this export configuration, this custom export service is used. Implementing a custom export service is again standard Symfony implementation, so you need to create the service, define it as a service in the container with a special tag, and this time this Pimcore Data Hub File Export Exporter tag, and the implementation itself here needs to either export existing ones, which is recommended because then you don't need to do all the work by yourself. Of course, you also could start from scratch and just implement or extend the abstract class. And this should give you really all the possibilities you need to even further customize the whole export process.
In terms of the technical details, there are a couple of things important to know about. First, since the data is delivered directly out of Elasticsearch, it also needs to be indexed into Elasticsearch, and so we need to discuss the indexing process in detail. Second, we'll have a look at the possibilities for configuring nice names and aggregations. And third, we will discuss in detail all the available REST calls of the endpoint. Let's start with the indexing process.
The indexing process runs completely transparent in the background, so normally you don't need to care about it. Still, sometimes, especially as developer, it's good to know how it's working. Every simple REST API endpoint creates a couple of indices, one for the assets if they are activated, one for the asset folders, then one for every added data object class, and one for the data object folders. That is necessary because there is only one type per index supported in Elasticsearch, and the mapping for the different entities should be different. And that results then in a list of indices. For example, for our front-end car, a front-end app endpoint here, we have this car index, we have object folder, asset folder, manufacturer, and an asset index. In case of a mapping update due to a schema change in the configuration that cannot be applied on the fly by Elasticsearch, Pimcore creates a new index with the new mapping and then reindexes all the data from the old index into the new index and then switches an alias. And that's the reason why every index here has the suffix even or odd, and why we have an alias for every index that doesn't have this suffix here. And for all the requests from the endpoint, always these aliases are used. The mapping itself is quite simple. We have a couple of system attributes, and then we have, in case for the data objects, for every configured data attribute, one data attribute in the index. Image data types and numeric data types are treated with a special mapping. And all the other data types have a standard text mapping. That means we have a keyword mapping for all the filters for the aggregations, and then we have an additional text mapping which is then used for all the full text searches. For the assets, it looks similar. We have again a couple of system attributes here, and then at some point we have this metadata node here which contains all the metadata of the assets. Since we don't have a class definition for the asset metadata and we don't know what actual metadata is there, we use a dynamic mapping here, so all the mapping is added dynamically. It's always the case that all the asset metadata is indexed to the index. There is no configuration possibility to just map a couple of the asset metadata. The indexing process itself takes care in the background and is done with a queue. That means every time an asset or data object is updated, it's added to a queue, and then we have this process here which is called Data Hub Simple REST Process Queue, which then processes this queue and updates all the indices of the REST API endpoints. In the configuration editor of the REST API endpoints, we also have an information about the current status of the queue, and there we see the number of items that are in this queue and need to be indexed. The Label Settings tab allows to define nice names for all the attributes that are included in the endpoint, which then can be used, for example, in the front-end applications as labels for the data attributes. The list of all the attributes is calculated directly based on the data in the index, and it is not based on the mapping information. That is because, especially for the asset metadata, we don't have a mapping information, and only the index itself knows what actual data attributes we have. And this has the consequence that the data needs to be indexed first before this list can be populated. And that means that in the beginning, when starting configuring a new endpoint, this list will be empty, or also when adding new data attributes to the schema of data objects, these new attributes will not appear in this list right away. You need to save the endpoint first and make sure that the process queue is processed, and then this list will be populated and contains all the attributes. The second option we have in this label settings tab here is this use in aggregations checkbox. And this allows us to define which of the data attributes should be included in the aggregations of the endpoint. And what that means, we will see in the next video.
Next, we'll have a look at how controllers, actions, and templates need to look like in Pimcore.
The Pimcore MVC of documents is based on the Symfony MVC, which means that controllers are standard Symfony controllers that can be located in any bundle which is registered, or of course also in the application namespace directly. As for example, we have it here in our demo application, where we have this controller namespace with all our controllers. Controllers are Symfony default controllers, so they pretty much have no requirements at all. They are just standard PHP classes with a couple of methods, and these PHP classes need to be registered as services in the Symfony container. There is though this frontend controller base class, which comes with Pimcore and adds some useful functionality when it comes to working with Pimcore. So you might want to extend this base class, but you actually don't need to extend it if you don't need the functionality. Actions themselves are again Symfony standard. That means they are just methods in your controller classes. Let's maybe just create an Academy action. This action suffix here is actually something that Symfony doesn't recommend to do anymore. In Pimcore context, it is still useful as the selection list in the document configuration depends on it, but actually it's really just optional. You also can leave it away here. Besides that, actions are really Symfony standard, so of course you can also inject any services here, like for example the request object or any other service that you need in your action. You can then do some stuff here in the action, do your service calls, do your calculations, whatever you want to do in the action here, and then in the end return some response object with some content in it. Of course, you also can use templates for generating the response content. For rendering templates, Pimcore follows Symfony standards and uses the Twig templating engine. So to render templates, you either can use this render method here and provide the template as a parameter, or choose any other method of Symfony to render templates and then return the corresponding responses. As an alternative, you also can use this template notation here, which is provided by the Symfony framework bundle. In this case, you just need to return an array of all the parameters you want to have available in your template, and Symfony will locate the template itself based on the controller and action naming conventions and render the template and return the corresponding response. This is important to know because we will return to this in a second. The template itself is then pretty much standard. It's a Twig template that can be located anywhere in your application, in any bundle, or also of course in your application here, for example in this templates folder. So let's maybe just create a template for our Academy action. The templates are Twig templates. They also follow the Twig naming conventions, and you can utilize the full power of Twig here in your templates. For now, we just create a very simple template with an empty head here and a very basic body with just one simple headline and maybe one paragraph with this is some Academy content. And then we need to go back to our controller and specify in our controller action that we want to render this template now. Let's for now just use this render here and specify the template we just created. And now we have already prepared our controller and our template to be used in Pimcore documents. And yeah, let's just switch back into the Pimcore backend and create a new document, an empty one, that now just uses our new controller action. And there we can now specify in the CO settings, in the CO and settings tab here, that we want to specify our controller. And there we can now select our default controller Academy action and so say that this document should use our Academy action. The template setting here is optional. If you don't specify a template here, either your controller needs to specify the template with this render as we did it here and return a finished response, or it needs to use this template annotation here and return a parameters array so that Symfony then looks for the actual template. If your controller uses the template annotation, then you also can override the template here with this setting. So you can specify with this setting a different template that should be used for rendering. It's important to know though, if your controller already returns a finished response object, like it would return if you use this render here, then this template setting doesn't have any influence to the template anymore and cannot change the template anymore. So important to know, if you want to allow your editor to specify the template here, then you need to use the template annotation in your controller. But for now we leave it empty because we define the template in the controller already. And now we go back to our edit tab, reload our document, and now we see that the document now renders or uses the Academy action for rendering the content. Let's have a more detailed look at the template itself. Of course, you now can create multiple templates with different content, with different structure, but in most of the cases when you have multiple templates within one web application, there are common parts of templates. Like you will have a head part where you include all the common style sheets. You maybe also will have a header within your body tag where you specify your navigation, for example, or other common parts of your templates. Same goes for the footer of your templates. So that you don't need to copy all the time the head part and the body parts, which are common to all the templates, Twig offers you a concept that is called template inheritance. The template inheritance allows you to build a base layout template, for example, like this one here, which then includes all the common parts, like all the includes of the style sheets in the head part, but also all common parts in your body tag, like for example the navigation and these kind of things. And then it defines so-called blocks, which are entry points that can be overridden by child templates. So with the template inheritance, you have the possibility to extend such layout files and then add or override certain blocks and specify your own content in these blocks here. To use such a layout file, we need to use a Twig function which is called extends, and then we just define the layout we want to extend. Of course, one web application can contain multiple layouts, or in general you can create multiple inheritance levels here, and then the layout itself only overrides a certain block. So we need to define the block that we want to override. All the HTML and body tags and these kind of things we don't need anymore. We just need the actual content we want to inject into this block, and then we define an end block here, and this is already actually it. When we now go back to our Pimcore backend here and reload our template, we see that now our content is within the whole application layout and with all the header information, the navigation bar, the footer, these kind of things. So now we have placed our template into the application layout quite nicely. Now we have already a pretty nice looking template, but it's still a bit disappointing for our editors because they cannot change anything within our template. They cannot change this headline here, they cannot change the text block here, they cannot assign an image or whatsoever. They are really restricted and cannot do anything with our template. To make templates editable for editors, Pimcore has a concept that is called editables. And let's just switch back to our template here and see how we can use these editables to make our template editable. Actually, editables are just simple twig functions that are provided by Pimcore, and you can use these twig functions at locations where you want to allow an editor to change the content of your template. So let's start, for example, with this headline here. There we use now a twig function which is called Pimcore input. And this twig function now creates an editable, an input editable, which allows to input a text in this headline here. And we give it a name, this editable here. So editables need to have a unique name. And now we have made our template at this point editable and allow the editor to specify a headline. Same we do for our text block here. There we choose a different editable, which is called what you see is what you get, that creates a what you see is what you get field. We call it content. And then once we have saved our template, we now go back to Pimcore backend, reload our document, and we already see the places where now the editor can change the content of the document. So for example, the editor can now define this is a nice headline, can add some text to this what you see is what you get field here, and so really can save the content directly to the document and not define it by the template anymore. Pimcore has a pretty long list of editables available, which are of course all documented in our documentation. We have editables like this input field or like the what you see is what you get field that we just used, but there are also a lot of different ones like checkbox, like a date field, like an image field, like a numeric field, like a select field, text area, and so on and so on. So really a wide range of different editables you can use to make your templates editable for the editor. Let's maybe just add another editable to our template, in this case an image editable to be able to add images to our template. Again, same principle, use twig functions, in this case this Pimcore image function, give it a name, and then we have already done the most important part. We have created an image editable with the name image. But at this point we maybe don't want to use the original image, which is maybe a high resolution image, a very big image. We want to use a thumbnail. And for that we can specify additional options to our editable, which we can apply here with this options array. And what options are actually available is documented in the documentation. So let's open up the image editable documentation, and there we have already the whole list of all the possible configuration options, like title, like width, like height, and like the thumbnail configuration. And this is actually already what we're looking for. There we can define the thumbnail definition that should be used for this image editable here. And there we need to provide a name of a thumbnail definition that is defined here in the Pimcore backend. We will discuss these thumbnail definitions in a later course, so don't get confused at this point. We just use an existing one, which is this example rotate here, which scales the image by width and then rotates it a bit. And we just use this name here and add it to our configuration of our editable. And then we go back to our document, reload the document, and there we have already now this drop target here. So this is something general. If you see this symbol here in Pimcore, this means that this is a drop target, and that you can drop some content there. In our case, we can drop an image. So let's just go for an image here, drag and drop this, and there we see already Pimcore now uses the thumbnail configuration we defined. It rotates the image, it reduces the size, and so we have now the possibility to add images to our documents. This editable principle is quite a really simple principle, but a very powerful principle to make the editables, edit documents, the templates editable for an editor. This editable principle is quite a simple principle, but it's also really a powerful principle to make the templates editable for an editor. And it's also really flexible because you can do a lot of things there. And now, of course, an editor can add additional instances of the templates. So, for example, can create an Academy3 document, and then the editor again needs to specify in the SEO and Settings tab the controller action. And well, actually, this might be already a bit annoying for the editor because the editor might be overwhelmed. He or she does not know what to do in this section. And actually, there is an option or a configuration to overcome this, and this configuration is called document types. Before we open up the document types, let's quickly delete this Academy document here, and there we open up the document types. And with these document types, a developer can specify which document types with which controllers, with which templates an editor should be able to create. And so let's, for example, just create the Academy document type, where we now again choose from our default controller the Academy action. We could specify also a template, specify to which page type this should be applied to. And that's actually already it. And now an editor can just create a new Academy document with this shortcut here, and when he creates this document, then the controller settings are already predefined and the editor sees the correct template right away and can start entering the content. So now we have a sort of nice looking template, and we have the possibility for the editor to change the content of the template. But still, the editor is quite restricted when it comes to change the structure and organize the content, because he or she always has to stick to the editables that are defined in the template. There is no option to add additional templates or change the structure. To overcome this limitation, Pimcore has two more concepts, and the first of these concepts is an editable that is called block editable. This block editable allows to repeat certain components, certain sets of editables a limited or unlimited time, and so give the editor much more possibilities in terms of building up the document pages. And to do so, let's just get ourselves this line here and then switch back to our template. And what we now want to do is to repeat this, what you see is what you get editable and this image editable multiple times. And to do so, let's just create this for loop and use this Pimcore block function where we define this block editable. Then we just add these editables here, and in the end we of course need to close the for loop. And when we now switch back to our Pimcore backend and reload the document, we see there is this block control where we can now add one or multiple items, and there we see now that the editor can now add the text content multiple times and the image content multiple times. So let's just add the text here and add different images here. So now the editor has more flexibility in terms of building up the pages. Of course, we also can add additional block entries afterwards. So we can just add one here, or we also can add some in the beginning. We can change the order of the block entries. So at least a certain amount of flexibility is now there when it comes to building up the websites.
Now our quite nice looking template is a bit more flexible, because the editor now can repeat certain template parts multiple times. On the other side, it's still quite limited, because the editor only can repeat template parts that are defined directly in the template file. He or she cannot compose the document page out of different components. If we want to provide this flexibility, we can use the concept of area bricks. Area bricks allow to define reusable template components and allow the editor to compose the document pages with great flexibility. Area bricks are something that needs to be defined by developers. Pimcore does not provide any default area bricks, and so they are always specific to your solution. Once the developer has defined area bricks and activated them for certain templates, the editor can add them via drag and drop to the document pages. Let's have a look at our demo application and see how this works.
For this, we just create a new document of the type content page. And as soon as the template of a document allows area bricks, there is this green plus in the upper corner here, which shows you a list of all the available area bricks. And now the editor can just choose these area bricks, drag them to the document, and so compose the document page and add all the content he wants to have. So we can just, of course, add multiple area bricks. The image here, we can, of course, also change the order of them later on, so we can just exchange the order. We can, of course, also add more afterwards. So there the editor then can compose his document page with huge flexibility. Let's create the sample area brick and add this area brick to the template we created before. And to do so, we need to go back to our IDE and into the source code. For area bricks, we need to create at least two files, one PHP class, which contains a lot of meta information and also can contain some additional logic. And then, in addition to this PHP class, we also need to create a template file for the area brick. Let's start with the PHP class, which should be located in the document area brick namespace. You also can move this class to other namespaces, but then you need to tell Pimcore where to load these area bricks from with some additional configuration. With the document area brick namespace here, there is some auto-loading functionality available, and Pimcore also creates some services for these area bricks here automatically. So let's just create a new class here, which is called Academy in this case. And important for these PHP classes is that at some place in their class hierarchy, they need to implement the area brick interface of Pimcore. And of course, there are also some abstract classes available, which makes sense to implement because they provide a lot of default functionality. And then you just need to override some additional functions to provide at least some meta information. Like, for example, the getName, which defines the name of the area brick. So let's call it Academy area brick, for example. Then there is also a description function, which can define some description for the area brick. And then there are, as you maybe already have seen, a lot of additional functions that are available where you can override the default behavior and provide additional meta information. So for example, you can define the HTML tags that should be used for the area bricks. You can also define the icon and additional things. One quite important function though is this action function, which provides you a place where you can put certain business logic into, which should not go into the template, of course, but also you cannot put into the controllers because, of course, area bricks you can use in multiple controller actions. So this would be the place where you can put some calculations, some operations for your templates, and also, of course, service calls, since the area brick classes here are also services. You can of course use dependency injection for them. So once we have created our PHP class, we now are ready for creating the template file for this area brick. And the template files are located either in the resources folder of a bundle or in the templates folder of your application. So let's go for the templates folder, and there is this areas folder. Then we need to create an additional folder which is called like our area brick, so in this case Academy, and there we create a view file which is again a standard Twig view file, so we call it view.html.twig, and there now goes our view and template code for the area brick. As this is a normal template, you of course can use any kind of markup here. You can use all the Twig functionality, and of course you also can use all the Pimcore editables. For that, let's just go to our Academy template here, and let's migrate the content that we before created with this Pimcore block here to the area brick. So let's just copy these two editables here, what you see is what you get editable and the image editable, and add it to our template of the area brick. And so we now have already created the template for the area brick. And that are already the most important things you need to do when you create an area brick. At this point, one thing is left. It makes sense to clear the cache here at this point in order to rebuild the Symfony container, register all the area brick services, and make sure that they are loaded properly. And then the next step is to go to the template where we want to add the newly created Academy area brick, and this is our Academy template, and there we need to define now that we want to allow area bricks and allow the editor to add the Academy area brick, and for that we use another Pimcore editable which is called the area block. Again, we define some name here, and then again we can also specify some additional configuration options, and in this case we now want to define the allowed option, which defines which area bricks are allowed at this place. If we don't define this allowed option here, then all the area bricks that are registered in the systems are allowed. So for now, let's just allow the Academy area brick and see how this looks like in the Pimcore backend now. So let's reload our template, and there we see now that we have available this plus here, where we now can add the Academy area brick as we defined it before. So we can add now again some texts. We can of course also add again some images here, and the editor of course also can add this area brick multiple times again. If we want to allow additional area bricks here, let's just go back to our template and allow additional area bricks here. For example, what you see is what you get area brick and image area brick and whatever bricks that are available in our current setup. And when we now go back to our template, reload the template, then we see now that we have additional area bricks available and that the editor can now just add them as he likes and compose the document pages in a really flexible way. The next thing I want to discuss are a few details when working with editables and working with the edit mode of Pimcore. And for that, let's just have a look at the preview here and see the markup that Pimcore generates for this image here, which is not just a simple image markup, an image tag, it's a whole picture tag with additional source sets and also this image tag here. And that's because, let's maybe go back to our template here. In this case, we are using this Pimcore image editable function, and there Pimcore automatically generates all the necessary markup, provides all the necessary information like the width, the height, the source set, and all these kind of things, so the whole picture tag. But sometimes maybe we want to use some more custom markup and don't want to use the default markup the Pimcore creates, so we want to have more flexibility and more influence how this markup should look like for the outside world. To do so, we need to decouple the edit mode from the actual output that is sent to the browser in the outside world. And for that, there is an important variable available, which is set to each template, and this variable is called edit mode. This edit mode variable is set to true when the template is rendered within the Pimcore document edit mode, so within the Pimcore backend when the editor can edit the template content. And this edit mode variable is of course available to any controller action templates as well as to the area brick templates. And as it's a standard twig template variable, we can use it, for example, in if statements. And let's just do this. If edit mode, and then of course we need some else maybe, and some end if at the end. And with that edit mode variable, now we can decouple the presentation in the edit mode from the presentation to the outside world. Like for example, providing additional information to the edit mode. So let's maybe just add here some additional text, add some image here, so some documentation, some instructions for the editors. So we really can provide additional information that is just visible in the edit mode. And of course also the other way around, we also can provide special markup to the outside world. For example, we can provide a special markup for the image that can be different from that Pimcore creates by default when just using this image tag here. And let's just do this. Let's just create a custom markup for the image, which of course will be much nicer than the original one. Well, maybe not really, but it should show you how you can use the edit mode variable here in this context. And for that, let's just create an image tag here, use the source attribute, and close the image tag again. And now we want to use, of course, the same image as we have assigned here in this edit mode. And for that, we can use again this Pimcore image twig function and use the same name here, which is important. And then it's important to know that these editable functions here return completely normal PHP objects, which of course have additional methods that you can call. As for example, we can call here in this case the source method, which returns us just the source of the image. Which methods are available, you of course see also in our documentation. So for example, here we have the input, which has methods like getData and isEmpty. Or we also have, of course, the image editable, which has methods like getSource, that we just used, but also other methods like getThumbnail, or also like the isEmpty method. The isEmpty method might be quite useful because there you can check if there is any data assigned to the editable or not. So maybe just also use this method here in this context. So again, Pimcore image, and then isEmpty here. And then we need to close this again. And there it's important, of course, that we just say if not empty, because we just want to print out the image if it's not empty. And now we go back to our Pimcore backend and go back to the edit mode, reload the edit mode. There now we should see some additional content here, some additional description that defines or gives the editor some hints what he or she should do there. And we now go for the preview, and there it reloads automatically. There we see already, okay, now the nice image tag, the custom image tag that we created is used, which now uses the original image, which is not so good at this case. So maybe let's just go back and use not the original one, but say get thumbnail, which is another method, and then we just use the thumbnail as we have it in the edit mode here. And then when we go back and reload our preview, then we see that Pimcore now uses again the thumbnail, but still uses our custom image markup that we just created. Long story short, this example here shows us two important aspects. First of all, with the edit mode variable, you can separate and decouple the edit mode and the presentation in the edit mode in the Pimcore backend and the presentation in the frontend to the outside world. And the second thing is that you can work with edit tables not only by adding them and so providing some input fields for the editors in edit mode, but also you really can just use the edit tables and you call functions on them and respond to certain user inputs, certain content, and also just get out certain information for custom markup rendering, as we do here with the source to the thumbnail of the image that is assigned to this image editable. In terms of the Elasticsearch index structure, there is one important thing to know about, and that is that the abstract Elasticsearch tracker does not create an index that exactly matches the getIndexedName value, but it creates an index based on the following schema. It uses the index name and then it adds a suffix for the current year and the current month. And the abstract Elasticsearch tracker creates an index every time the month changes, so it really creates always an index that is fitting the current month. In addition to the index itself, it also creates an index alias that is really then fitting exactly the index name, and this index alias then in aliases to all the different indices that are created by the abstract Elasticsearch tracker. And the alias then is also used for all this querying stuff. So let's have maybe a look into Kibana and see how this is working. So we have one index that is based on this index name Enterprise Portal Engine Statistics download here, and the index itself then has the suffix for the year and the month. And when we have a look at the aliases, then we see that this index here has an alias for this generic name Enterprise Portal Engine Statistics download. And yeah, the mapping itself then from the indices is as it is defined in the custom tracker implementation. The reason why we do this is that we easily allow housekeeping, because so we always have all the events that are tracked for a month in a separate index, and therefore we easily can remove or archive old entries in older indices that we don't want to use anymore in any reports. And so this can be done very easily. This is not something that is done automatically, so this housekeeping has to be done by the administrator of the Elasticsearch cluster, but this index structure here gives him a great possibility to do so.
One more feature the Statistics Explorer bundle provides is an event tracking feature. It allows tracking events to an Elasticsearch index, and this Elasticsearch index then can be used as a data source for the Statistics Explorer, and reports can be created based on it.
For tracking events, you need to implement an event tracker that tracks what you want to track. Therefore, the Statistics Explorer bundle provides you with an abstract Elasticsearch tracker that takes care about all the Elasticsearch index management and all the Elasticsearch communication. And you just need to implement 3 abstract methods in your custom implementation, which are the getIndexedName method, buildMappingArray, and the trackEvent method. Let's have a look at a dummy tracker, how this implementation could look like. So the getIndexedName method just returns the name of the index in Elasticsearch. The buildMappingArray returns the mapping definition for the index. So based on this definition, the mapping in the Elasticsearch index is created, and there you can define all the different data attributes and sub-attributes and these kind of things you want to have in your index. And then last but not least, the track event method then takes a parameters array, and then based on this parameters array, it creates a values array that needs to fit the data structure you defined in your mapping, and then actually calls this toTrack event method, gives this values parameter as a parameter, and then the event is tracked to Elasticsearch. So all the Elasticsearch communication and these kind of things are done within this toTrack event method that you just call in this case. And as soon as you have implemented your custom tracker, then you need to register it as a service, and then wherever you want to use it, inject it, for example in your controller or in other services, and then just call the track event method with all the parameters you have, and then the event gets tracked to your Elasticsearch index.
Up to now, the personalization options we discussed were quite manual. That's great for the editor because they provide great flexibility, but on the other hand, they also require lots of manual work, especially for content creation. The great thing is that all the visitor information that is available in the system is also accessible via an API, and therefore it's easily possible to set up a more automatic approach for personalization. We just use the available visitor information and personalize whatever we like in our controllers or in our template. And so we compose and personalize the content based on different rules and aspects. We even can go one step further because the automatic approach for personalization does not need so much manual work. We can personalize on a much more fine-grained level. That means we don't use the customer target groups as a base level for the personalization, but we can personalize on a much more individual way. To do so, we can reuse a concept that we already discussed in the context of the customer management framework, which are the customer segments. In comparison to the target groups, which are more high level, and most likely there are only a couple of target groups in the system because they require lots of manual work, the customer segments allow us to describe a customer and its interests in a more fine-grained way. In addition to that, they also allow us to tag the content and so define which content is most likely relevant for what type of customers. Having said that, the basic principle for the automatic personalization stays the same as for the manual personalization. That means, first of all, we need to profile our visitors, for example by tracking the segments of the content they open, and then use this information, this profiling information, and personalize the content based on it. For tracking the segments, there are a couple of options available.
Before we discuss in detail the options how to track the segments, let's see where the segments are tracked to, and this is of course the visitor info. There is a special section which also can be seen in the targeting toolbar here, which is called CMF tracked segments, and there all the segments that are tracked are listed with their corresponding count, so how often they are tracked for the current visitor. For tracking the segments, there are three different options to track the segment. The first option is to use the global targeting rules. There you can define a targeting rule that has a special action which is called CMF track segment, and this action defines which segment should be tracked once the action scope and the conditions apply. The track segment action is shipped with the customer management framework, so it's not available in a default Pimcore, but as soon as you have installed the customer management framework, you can also use this CMF track segment action, and there you just assign the segment you want to track, and then the segment is tracked to the visitor info. The second option to track segments is another customer management framework feature. The main goal of this feature is to tag the content with certain customer segments. So it can be configured which content, so documents, assets or data objects, should be able to be tagged. And when we tag the documents, then these assigned segments that are assigned with this tagging here are tracked automatically as soon as the visitor opens up the corresponding page. So there we see, for example, now that Chevrolet and full size got tracked now to our current visitor info. Discussing the third option of the segment tracking brings us step by step closer to a full automatic approach of segment tracking, and I'm going to explain that in the context of data objects. As mentioned before, the data objects also can be tagged with the customer segments, like we have it here, for example, for our category object. And there we use the same functionality as we saw before by the documents provided by the customer management framework. The only difference is that in the context of data objects, the segment tracking doesn't happen automatically. You have to take care about the segment tracking by yourself. And this can be seen in the implementation of our demo application, here in this listing action, which is responsible for the category listing page. And there we introduced an additional tracking helper service. And this tracking helper service has this method track segments for category, which tracks the segment for the given category. And there are actually two important lines. The first line is here where we use the segment manager that is provided by the customer management framework and get the segments for a given element, which reads out all the tagged segments of the given category objects. And then we use these segments and use the segment tracker and this track segments method to track the given segments to the current visitor info. So the third option for tracking segments is to use the segment tracker, which is also a service of the customer management framework, and use the track segments method there to track the segments via code. And there you already see that this track segments method, of course, can be called in any context, and you also can, of course, decide by your custom code where these segments come from. The first example is we use the tagged segments from this segment tagging functionality, but of course we also could use some different functionality to calculate segments. For example, we have this here for the products in our demo application, where we said that we don't want to tag all the products by its own, but we want to calculate the segments based on certain data attributes of the products. And there we introduced this special segment getter, which calculates the segments, for example, of the cars based on the attribute manufacturer, based on the car class, and based on the body style. And there we create the segments based with the segment manager, which is also shipped by the customer management framework. And then we get a list of segments for each data object, for each product here. And these segments we use then for tracking segments with the segment tracker. And this method is now called every time a user opens up a detail page. So there we have the detail page action, and there we track the segments, and so we fully automatic track the segments based on any data attributes that are assigned to the current product.
When it comes to updating Pimcore, Pimcore follows pretty much the Composer standards, which means you need to update your project composer.json file with new Pimcore version and related dependencies, and afterwards run composer update command. These steps are also available in the documentation. So first important step is to check the upgrade notes before running composer update command. In the upgrade notes, you will find all the important changes that needs to be taken care of before running the update. Second step is to update your compose.json file with the desired target version for Pimcore package. And finally, run the composer update command. If there are migrations that Pimcore needs to execute in turn to get data or data structure changes or configuration changes and so on, Pimcore provides migrations which are based on doctrine migrations that will be executed automatically during the composer update. We can also check the composer update output log to see if the migrations are executed successfully or if there are errors during the execution of migrations. So at the moment, we are at the latest version, so there are no migrations that needs to be executed. You can also run migrations manually. Let's say if there are errors during the execution of the migrations and you fix the problem, afterwards you can run the migration manually by running command doctrine migrations migrate with the prefix option Pimcore bundle core bundle. This prefix option is to run bundle specific migrations. You can also use doctrine migration execute command to run specific migrations. Once the new Pimcore version is installed and the migrations are executed successfully, now it's time to test your application and fix the issues.
Hello and welcome to this session of Pimcore Insights. This session is all about administration of Pimcore. One of the most important parts of the administration of Pimcore is the user management, and that's the first aspect we're having to look at. Pimcore provides a role-based user management where you can set up so-called user roles and then of course specify users that have one or multiple roles. Users and roles can be set up here in the setting menu, and let's just have a look at the roles first and create a demo role and see what can be configured on role level. First of all, per role you can specify which perspectives should be available for the users of this role. Then we have a whole list of different permissions that you can apply. These permissions are on the one side mainly functionality that is hidden somewhere in the main menu, and also the base permission for assets, for documents, and also for the data objects. Then further down you can specify which types of elements can be created by users of a certain role for document types and for data object classes. And you also can specify for the shared translations which languages should be available to view and which languages should be allowed to edit. In addition to the basic permissions, there is then the workspaces concept, and this workspaces concept now defines which subtrees of the main entities of the documents, of the assets, and of the data objects should be accessible and editable by the corresponding users. And these workspaces can be defined by just adding a new workspace and then specifying, for example, that our user should only have access to the DE tree, and there he's allowed to list, to view the documents, to save the documents, maybe to publish them, maybe to unpublish them, but not to delete them, not to rename them. He's allowed to create new documents and maybe sees the settings, or maybe even don't see the settings of these documents. Same goes, of course, for assets. Same principle. And same also, of course, goes for the data objects, where I have a couple of more settings. Especially there I have some special settings which allow me to specify in the combination of localized fields which languages should be shown to the user and which languages should be editable by the user, and also which custom layouts, in this case we don't have any, but which custom layouts should be available to the user. And that's about it, what I can define on role level. Let's have a look at the users and create a new demo user, for example. And yeah, first of all, a user now has, of course, a username and can have a password. You can activate two-factor authentication for a certain user. And yeah, user has some meta information like the image, which would be shown here down in the left corner, and your first name, last name, email. The user can specify the language of the Pimcore admin interface, so in which language he wants to see all the admin interface, and then I can specify which roles should be assigned to this user. In addition to assignment of the roles, also the user itself can have additional permissions. So you can, all the settings that you can set up on role level, you can also set up on user level, like for example the perspectives here, or down the road all the permissions that we also already saw at the role level, also all the types to create, and of course also the workspaces. When a user has multiple roles or roles and user-specific permission settings, then the permissions are merged optimistically. That means once a permission is given to some resource, then the user has the permission to this resource. In addition to the permission settings, there are a couple of additional settings that are on user level, like for example, can specify the language order of, for example, the localized fields. So there a user can, for example, say that he always wants to see German first and English second because he is the German-speaking user. And also there are a couple of settings in terms of if there should be shown a welcome screen on startup to memorize the open tabs and these kind of things. Another permission is the admin permission, and once a user is admin, then he always has access to everything, and therefore you also cannot specify any workspaces or any additional permissions anymore. So once a user is admin, then he is admin and is allowed to do everything. So now we have saved the user, and let's test if our user settings are as expected. And to do so, there is another quite useful feature in the user menu of Pimcore, which is this button here, log in as this user in a different browser, which gives you some URL with some token and allows you to log in as this user, to impersonate as this user. And there we see already our permissions are happening. So we see a really reduced menu on the left side with only the search available and the open shortcuts. And also in the data entities, we have really reduced views on the data. So we have only the DE tree in the documents available. We have only the examples of the assets available. And we also, of course, have only the blog folder of the blog objects available. And that's about the most important things. Of course, the user permissions are not only checked client-side and reduced client-side, they are also checked server-side. So as soon as you have some request that checks or modifies any data that you are not allowed to modify, then of course also there is a server-side check to make sure that all the permissions apply. Of course, I can also use the data object data in templates. So in this case, for example, not returning a JSON response, but maybe really just to render a template view. Let's just quickly do this. Say, for example, we want to put our product listing onto the view. And now we need to create a template for our controller action, which is in the default controller. There we create a new PHP file, which is data object html.php. Let's just copy our header information from an existing template here. Also extend the layout template that it looks a bit nicer. And there now in the template, I can again work with the data. For example, I can just make another for each where I say this product listing as product. And now, fill out some markup where I maybe just get the product data from the product objects, like for example get name, and then I can do here product get description and yeah, at some point maybe the price, product get price, and then let's just make a horizontal line here now that we separate this. And this is actually already yeah, a simple template and shows how I can access the product data also directly within my template. Of course, this can also be done within the Twig templates. And yeah, let's have a look if it's really working. Reload our action, and there we see now our content is rendered as a template. In terms of the technical details, we need to discuss two aspects. First aspect is the concept of the visitor info, which provides the API to access all the information that is available about the current visitor in our server-side code. The second aspect we need to discuss is the targeting storage, which is responsible to store all the visitor information to some storage place. Let's start with the visitor info.
The visitor info contains all the information that is available of the current visitor. You also see that information in the targeting toolbar, like the visitor ID, like the matched rules, like the assigned target groups, for example, and other information. And you can access this information by just using the visitor info storage, which is a service that you can inject. And there you can check if the current visitor has a visitor info. And if so, for example, just print it out. Or of course access all the getters and setters and use the information there. And there you can see you have information like visitor ID, like the matching targeting rules, like the assigned target groups, also with the account and all the other information that is available. In terms of the targeting storage, you find all the detailed information in our documentation here in this targeting storage page. And yeah, the most important thing to know is that the targeting storage defines where all the information that is collected about the current visitor is stored. There are a couple of different implementations available for this storage. There is cookie, there is a DB implementation, there is a Redis implementation and a session-based implementation. By default, the cookie implementation is used, a cookie JWT implementation. And yeah, this is important to know because, of course, the cookie is always sent with the request. And as a consequence of that, the request might get bigger and bigger if you collect a lot of information about the current visitor. Of course, you can also use alternative implementations like DB, Redis, or session-based implementation. And we listed here all the pros and cons so that you can decide which is the best implementation for your use case. Besides using the tracked segments as a data source for a more sophisticated visitor profiling, they also can be used as a data source for a fully automatic personalization. Before we dig into the code and see how this can be done, let's have a look at our demo application and the example we implemented there. There we created a product teaser that uses the visitor info information and the tracked segments there for personalization of the content. And let's just add this teaser here in our new content page. Then we need to assign a couple of products as a fallback if there is no personalization information available yet. And when we open up the teaser page here, we see the content and the cars that we assigned in the Pimcore backend. And now let's maybe just open up some sports cars. Maybe let's visit some Jaguar cars here and open a couple of color variants. And when we now go back to the landing page, we see already that the content now of the personalized product teaser is Jaguar and sports cars. The personalization is done fully automatic based on the behavior of the visitor and based on the segments it got tracked on the detail pages, and the segments that are tracked on the detail pages are calculated based on data attributes of the corresponding product. So there is no need for any manual segment tagging or any manual content creation and assigning for personalized content for this teaser. The implementation is quite simple, and let's just have a look at the implementation of the personalized product teaser here in this area brick. And there we actually use the services we already know, like the visitor info storage, like the segment tracker, and also the segment manager. And what we actually do is that we use the segment tracker and extract the tracked segments out of the visitor info storage and filter it for a couple of allowed segment groups. In this case, we just filter for the car class and the manufacturer segments. And then we use this segment collection as a condition for the product list that delivers us the products out of the product index. The only requirement, of course, is that also in the product index, the segments are indexed that belong to the certain products. And based on this simple condition here, then the teaser returns the personalized cars that fit to the current visitor. This, of course, is only an example how the personalized content can be calculated, but this example shows quite impressive how easy it is to use the existing services provided by Pimcore and the customer management framework and create a personalized experience for the visitors. And the concept of using the segments is a really simple concept and also a really powerful concept because it's really generic. So it doesn't matter if you sell cars or shoes or anything else. The basic principle of tracking segments based on certain data attributes of your products and then also filtering these products based on these segments is always the same, and so it's really easy to create personalized product experiences.
Now that we have tracked the customer segments, we have them available in the visitor info. From there, we can use them as a fine-grained entity for visitor profiling and calculate target groups based on them, or we can directly use them for full-featured automatic personalization.
Let's start with using the tracked segments as a data source for more sophisticated calculation of target groups, and this can be done again with global targeting rules. Actually, we have already prepared one targeting rule that does exactly that, and this targeting rule has a special condition which is a has segment condition. Similar to the track segment action, also the has segment condition ships with the customer management framework and is available as soon as you have installed the customer management framework. And this has segment condition here checks if a customer has a segment assigned, either in the visitor info of the current visitor or in the customer object of the currently logged in customer. And then in addition to generally checking if the segment is assigned or not, we also can consider the weight. In this case, we want to make the condition true every second time the segment is tracked to the customer. And then we execute a certain action, and this action in this case, of course, is assigning a target group. So that means every second time the user gets tracked the segment sports car fan, then it is also assigned the target group sports car fan. So with this option you can do a real fine-grained and very sophisticated calculation of the target groups that should be assigned to the current user.
Documents not only can be used to create websites. Since the template is completely free, documents can also be used to deliver content to many different other output channels, like for example digital signage systems or web-to-print systems. Let's have a look at the web-to-print functionality of Pimcore. This web-to-print functionality follows the following principle, and this principle is to use as much functionality and as much available technology as we already have for the normal documents. That means the process for creating print documents looks as this chart here shows. First, create HTML templates by using all the technologies we already use for the normal documents, like HTML, like CSS, like JavaScript, like all the standard stack for creating normal HTML templates. Then, of course, use these HTML templates and make them editable with Pimcore by using all the editable functionality that Pimcore provides, with all the editables, all the area bricks, all the renderlets, for example. So really provide an editor the possibility to specify, to compose the content of his print deliverables. And then render this with Pimcore, but instead of delivering the result to a browser, convert this rendered HTML to a PDF by using a PDF converter. Currently, Pimcore supports two PDF converters, one open source, which is the WK-HTML to PDF, and one third-party commercial product, which is called PDF Reactor. But both follow the same principle. So let's have a look how does this look like actually in Pimcore, in the Pimcore backend. And for that, we switch into our advanced demo application, where we have also some demo catalogs, some demo web-to-print documents here. And yeah, before you can start with the web-to-print functionality, you have to activate this, because by default, the web-to-print functionality is not enabled. You have to enable it in the settings, and in these settings you also can specify which rendering tool you want to have, and then also some tool-specific settings like which version, which endpoint, which license, all these kind of things. Once the web-to-print module is activated, you have two additional document types you can create, which are the print pages and the print container. The first, or the most important one, is the print page, which is actually pretty much the same as the normal document page, which actually holds all the content that should be within your catalog. And in terms of technology, it's actually really completely the same as the normal document pages, which means you again have the MVC pattern in behind, you have some controller, you have some action, you have some template, you have all the editable functionality, you have all the print functionality, and the editor can compose the whole page with all the mechanisms, with all the concepts he already knows from the normal document pages. A print page does not necessarily need to be one print page when it comes on paper, so all the page breaks are done only by rendering. So one print page, of course, can also contain the content of multiple actual paper pages then. The special thing, or the special function of the print pages, is that you can generate the PDF of the print pages right within Pimcore with this additional tab here, generate and PDF, generate and preview PDF. And there, depending on the rendering engine, you have a few settings you can specify, and then directly generate the PDF directly within Pimcore. And then the whole process takes place that we saw in the chart before. So we are rendering the HTML out of Pimcore and then putting this HTML to the PDF renderer and get a completely finished rendered PDF as a result. This PDF can be really print ready. So for example, you also can activate printer marks that then really you have a PDF document that is quite ready for printing with a print agency. In addition to the print pages, we have also an additional and second document type, which is called the print container. And the print container is more or less something like a folder with an additional functionality of again creating a PDF. That means with print containers you can structure your catalog, you can collect chapters, you can create chapters, you can create whole catalogs, and this print container allow you to render a PDF that contains all the documents and all the content that is in child documents of the current container. So in this case, for example, you can create the PDF of all the chapter content, and of course when you switch to the print catalog you can also render the whole catalog, in this case with all the chapters in it. In addition to just producing content or just making content manually, of course it's also possible to create some automatic stuff, like for example a table of content, which is actually nothing else than a simple JavaScript that goes through all the content, looks for certain headlines, for certain HTML, CSS classes or something like that, and renders out all the occurrences. And of course you have also the possibility to then directly jump to the content and really provide a full-featured table of content. The template of your print pages, of course, has to consider certain special cases of the rendering engine. So you have to decide first which rendering engine you want to use, and then create your template and optimize this for this rendering engine. So there are a few specialities depending on the rendering engine that you need to take into consideration, but basically it's really just basic HTML and CSS, so there's nothing special about it. How these templates look like or can look like, you for example can look up in our demo application. You for sure can use the templates that we provided here, at least the base templates, like for example that you have this page-like visualization here in the edit mode, and also that you have all the page stuff on the PDF document, like for example the sidebars here or footers with page counts and these kind of things. Again, this is a quite simple principle with a quite huge impact, because with this functionality you easily can create print deliverables directly out of Pimcore by using all the data that is already managed in Pimcore anyway, for example for delivering other output channels like an e-commerce application or a normal website. So you can use the same assets, you can use of course the same data objects and reuse all the data, and again follow the principle of single source publishing even for print deliverables. There are three major approaches when it comes to create print deliverables. The first approach is the manual creative process. This means that all the print deliverables are created manually, most likely in a desktop publishing program like Adobe InDesign. In this case, Pimcore can be a data source for all the structured information and also all for the assets. For example, you can use plugins like Easy Catalog, which allow you to connect InDesign to external data feeds, like for example a data endpoint that is provided by Pimcore. And then the editor can load all the product data or all the other structured information directly into InDesign and use it for his print document. The second approach is the other extreme. It's the fully automation, which means that you just press one button and based on some rule set and of course on some data, a full catalog or other print deliverable is created. This of course can be done directly with Pimcore. Most likely this will be just one, for example, controller action that just does not return an HTML response, but for example a PDF response. And all the logic and all the data retrieving is implemented in the controller and in the template, and so the print document is created fully automatic. A use case for that would be, for example, a product data sheet which is provided on product detail pages within e-commerce applications, or even price lists, or maybe even simple catalogs. And in between these two quite opposite approaches, there is a third approach, which is called semi-automation, which allows you some manual interaction when creating print deliverables, but also has some kind of automation within, some kind of rule set that reduces the manual effort for the editor. And this semi-automation process is quite a wide range. You can decide how much automation you can have or you want to have in the process. And yeah, this semi-automation process is the typical use case for the print documents and for the built-in web-to-print functionality with the documents within Pimcore. Now, of course, the question is when to use what? Well, there is no strict rule set for that, and as always, it depends on the use case. A rule of thumb could be that if you have functionality that you want to reuse on multiple projects and that you want to provide in a bundle or so, then use parent class or traits. And if you have custom functionality that is project specific and you want to inject, then use class overrides. In the second example of the e-commerce framework, I want to show you how to work with cards. For that, I already prepared two controller actions. First action is an add to cart action, which adds a product to a certain cart, which is passed via a parameter. And the second action is then a cart listing action, which just again creates a JSON list of all the cart items that are in a certain cart. To work with cards, I have to use the cart manager, which is again an instance that I can retrieve via our e-commerce factory. So here I just get an instance of the factory and get a corresponding cart manager. The cart manager then allows me to create cards, and there is one specific method which is get or create cart by name, and this is, I think, the most important method here when it comes to working with cards. And there I can create a card and give him a name. In general, the e-commerce framework is set up that it can handle multiple cards within one user session. And yeah, this can be used in two things. First of all, of course, if my application needs to support multiple cards for a user, like for example in B2B applications where a user has multiple cards, one card for each end customer of his. And the second thing is that in the e-commerce framework, we don't have specific implementations for things like comparison lists or wish lists or something like that. We use also just card implementations or cards with specific names for this kind of functionality. So there is not much difference between a card and a wish list, and that's the reason why for wish lists, for example, we also just use cards with a specific name. So once we have a card, let's just use this card and add an item. Our item is now a product, and we also can specify account, for example, and a few additional parameters which are all optional. And then we need to save the card, and this is actually already it. This is all we need to do. When adding products to a card, these products need to implement now the iCheckoutable interface. Just iIndexable is not sufficient in this respect anymore. Yeah, and then let's just go back or go forward to our card list action. In this card list action, we again get our card, in this case the same card, and then we, for example, just loop through all the card items and create again or fill up our JSON array. And there we again, for example, have an ID with get item key, for example. We always have, of course, access to the actual product within the item, and then can call all the methods that are available in our product. And for example, we also can get, of course, the counts of an item. So now we have it. And then, yeah, we just return this one. And yeah, let's go back to our browser. Just open up the card add action with a specific product ID, for example. Then the product is added and the card list is rendered. And there we have now the listing of all the card elements that are in the card. When I now have a look at the second product ID, which is 56. So let's just open up again with another ID. Then we see we have now second product and first product in our card. The reason why I don't render a template at this point is just to show that the e-commerce framework itself doesn't force you to render templates and also doesn't ship with templates. You can, for example, just render these JSONs, which you then can use in an app, for example. But of course, you also can use all this implementation and services to render your custom templates. So instead of just returning here a JSON, you can render a template and visualize all the information of your card, in this case, in a certain template.